Hello and welcome to today's lesson about the lungs. I've put there our objectives for today if you want to have a read of those quickly. And as a starter activity, I want you to have a look at this diagram of the lungs and see if you can remember and label the key components. To try and help you, I'm going to label or number some of the components here. So if you want to pause the video and have a go at that. Right, so hopefully you should have labelled this as the trachea, this as the left bronchus. Something I want to clarify from last lesson, as if we're talking about more than one bronchus, so the left and right bronchi, then we use the word bronchi, which is the plural form of it. 3 is a bronchiole, and 4 are the alveoli. You might also have labelled this as the left lung and this as the right lung. So, included in this lesson, there is included a video and animation of how the ribs and diaphragm move to allow us to breathe in and out. It might be worth you pausing this video and going having a look at those now, because it's a bit easy to see if it's an animation rather than me talking. So, there are 2 structures that allow us to breathe in and breathe out. The ribs, or the rib cage, and between the ribs there's a set of antagonistic muscles called the intercostal muscles. We don't need to know too much about those at the moment, but we just do need to know that they allow the rib cage to change its shape and change its size. And then also this muscle under your lungs, which is called the diaphragm. If you take a really heavy breath in and hold your stomach just below your rib cage, you should be able to feel that muscle moving. So if you want to have a go at that now, just put your fingers about 3 or 4 centimeters above your belly button. Take a really big breath in, and you should be able to feel that diaphragm contract and become larger. And then as you breathe out, you should be able to feel it change shape. So, when we breathe in, the ribs move out, the diaphragm contracts and moves down. All of this process increases the volume in the chest cavity. Now that means that the pressure in the lung cavity in the lungs decreases. As a result of that, air, which will be the air pressure outside will be a higher pressure than the air inside, is forced in the mouth and nose into the lungs. When we breathe out, the ribs move down, again by changes in the shape of the intercostal muscles, and the diaphragm relaxes and moves up. This decreases the volume inside the chest cavity, which means that the pressure increases. Pressure in the lungs is now greater than the air pressure outside, so air is forced out of the mouth and nose. So if I was going to summarise that, the relationship between volume and pressure here, if I draw this box to represent a large volume, so this is when we breathe in, that means that the pressure inside the lungs is lower, which means the air pressure is higher outside than in, and air is forced into the lungs. If we look at what happens when we breathe out, then we have a smaller volume, and I'm abbreviating volume to VOL dot here, and a high pressure. This means that the pressure inside the lungs is higher than the air pressure, and therefore air is forced out of the lungs. So, as a summary to that, when we inhale, the ribs expand, and the diaphragm contracts and moves down. Again, the reason what happens here, we get a large volume and therefore a low pressure. When we exhale, the ribs move in, the diaphragm relaxes, and moves up. So we have a small volume and therefore a high pressure. So have a look back over maybe some of the notes here, make your own notes on it, and then when you are ready to, see if you can copy this table and fill it in. If you want to pause the video now to do this. So hopefully you have summarized this. So when we inhale, the diaphragm moves down. You could also have said that it contracts. The ribs move out. The volume inside the lungs increases, and therefore the pressure inside the lungs decreases. When we exhale, the diaphragm moves up. You could also say that it relaxes. The ribs move in. The volume inside the lungs decreases, and therefore the pressure increases. There are then 5 questions for you to have a go at. If you'd like to pause the video, and you should have then answered these questions, and here are the answers for you to check. Again, if you'd like to pause the video. So, the last thing that we have to have a look at is the effect of exercise on breathing rate. And we're going to summarise this in a flow chart. So I'm going to have to try and move out. So the effect of exercise on breathing rate and why we breathe more when we exercise. So the first thing we need to remember from our last lesson is that the process of respiration uses oxygen to convert energy from glucose in the mitochondria in every cell in your body. And just reminding ourselves here that respiration is not the process of breathing. Respiration is the chemical reaction that takes place in the mitochondria in every one of your cells that allows the body or the cell to convert energy from glucose into a more usable form. We need to recognise that when we exercise more, the muscles are going to need more energy conversion. Because they're being asked to do more work, they're going to need more energy conversion. Just going to zoom in on those two for a moment to make it a bit clearer in case you can't see it. So, as a summary, respiration uses oxygen to convert energy from glucose in the mitochondria, and then the muscles therefore need more energy when we are exercising. If the muscles need more energy when we're exercising, then we're going to see an increased rate of respiration in the cells. If we get an increased rate of respiration in the cells, more oxygen is needed in the cells. And if more oxygen is needed in the cells, then finally we can say we're going to have an increased rate of gas exchange in the lungs. And then finally, because of that, we will have a faster breathing rate. Okay, so if I just go back to the very top of this and summarise, respiration uses oxygen to convert energy from glucose in the mitochondria. Okay, remember, respiration is not breathing. Respiration is the chemical reaction that takes place in the mitochondria to convert energy from glucose, and it needs oxygen to do that. Muscles need more energy when we're exercising, which leads to an increased rate of respiration in the cells. More oxygen will be needed in the cells, and therefore we'll have an increased rate of gas exchange in the lungs, and therefore a faster breathing rate. And that's the end of this lesson. Thank you very much.